So let's find the resistance between point A and B. This is example 23 of HC Verma electricity. Each wire has a resistance R, and so let's find the resistance between A and B. Equivalent resistance is defined as the potential difference divided by the current. Let's say a current of I1 total. No, not I1. Let's say it's just I. I enters A. Because of the junction law, it gets divided. It see being divided here and here is exactly the same mathematically, because if you get divided here, you have the same number of steps to reach this point B. And if you get divided here, you have the same number of steps to reach B, and it's completely symmetrical. You can go by this way and also and this way also. So mathematically equivalent, you can just twist the cube and get the same points. So it will be current will be equally divided. So let's say it's getting divided by I1. Let's say, see, this is not symmetrical. You have just one step to reach B, just two steps to reach B. Actually, if you are here, can go through this part and this part. There is two steps. But if you are going through this lane, you have one, two, three, four steps, or one, two, three, four steps, or one, two, three, four steps. So it's not mathematically equivalent. So let's say there's a current of I2, and so there must be a current because of the junction law. If I1 is entering here, I2 minus I1. So that the net current I2, oh, sorry, the current here should be I1 minus I2. Did a small mistake there. I1 minus I2. I2 and I2 gets cut, and so I1 is the total current that remains, which was the original current that entered. Similarly, if this I1 gets divided equally into I2 and I1 minus I2, this I1 must also get divided since it's mathematically equivalent to this part into I2 and I1 minus I2. So some part must be I2 and some part must be I1 minus I2. But which is which? See, the closer one to B becomes I2. Once that's closer to B becomes I2, and the one that's farther becomes I1 minus I2. So since it's mathematically equivalent, one that's closer to B, which is this lane, it should become I2, and one that's farther, this lane, must become I1 minus I2. Okay. Now what? This I1 minus I2 comes down, and this I1 minus I2 also comes, and they both meet at this point and they both join together. Both the currents join together, and since electrons cannot escape out of the wire, they both get added. So here we have two I1 minus I2 current. I think I should put this in a bracket. Still dark, right? Now they would get added. Now what? Let's see for this. Okay, we have talked about just this I1 and this I1. We haven't talked about this lane AB. So this lane or this wire AB, since I is a total current, this so the current here must be 2 I1, no, I minus 2 I1, I minus 2 I1, because then only this I1 and I1 get subtracted, and I will be the total current that which originally hasn't. It's going. Now, mathematically, this point A and this point B are also equal. Why? We have sent the current through A. That was completely our choice. We sent the current through A. It's not written in the question, but we sent the current. What if we sent the current through B? And now current from B is reaching A. That way, this part will get I minus 2I1 current in this direction, and there will be an I1 current in this direction, and there will be an I1 current in this direction if we send the current from B. But it cannot happen that if we just reverse the polarity, we are sending the current through A. It cannot happen that if we just reverse the polarity, the current gets distributed differently. It cannot happen. Mathematically, nothing is different except for the direction of the electrons. So it cannot happen that if you reverse the polarity, the current gets distributed differently. So the current that is reaching that was coming from I must also be I1. And if we reverse the polarity of the current, I mean, if there was a battery, let's say, and there was the polarity, so the current going through this part must also be I1, because it would be the current going through this part if the current was actually entering from B. And if we have reversed the polarity, but the current distribution still should be same. So this part must get a current. This part, let's see the different color now. So this part must get a current of I1, and also this part must also get a current of I1, because I1 and I1 are getting separated for here. So I1 and this I1. Okay, all right. Now this I2 is entering from this wire, and we get an I1. The current, if we say that current is going in this direction, we are not sure. Maybe it's not going in this direction. But if it is, let's assume going in this direction, the current should be I2 minus I1. I2 minus I1. Because then only, oh sorry, no, I do this wrong. I did this wrong. I'm doing this wrong actually a lot of times now. I1 minus I2. Then only this I2 and this I2 will get nullified and we get an I1. If we assume the current to be in direction, the current could be in that direction, and then we'll have to reverse, subtract, add a minus sign and of all this. But we assume it's going in, so I1 minus I2 must be the current. So if we write the equations of what we have to find is the R equivalent is defined as the net potential difference between A and B upon the current. Now the current we sent is I. Let's for simplification's sake, I took a lowercase I, but it's harder to write a lowercase I. So let me just assume it's an uppercase I, and it's I1 and I2 similarly. So we sent an I current. So delta VAB upon I should be the equivalent resistance. The I could be anything. We could have varied. So we must get this delta VAB in some form of I, so that I gets divided and we get a constant as the answer. So let's find the change in potential of A and B in forms of I. So the change in potential between A and B is it's known. Uh, if we go from the shortest paths, V is equal to IR. And I here is I minus 2I1 R. This is the first equation. Second equation is delta Vs. Let's go from this path. I1, I2, I1. We get an I1 current, we get an I2 and an I1. So the I1 is getting added twice. So if 2I1 plus I2 times R as the potential difference between points A and B. Then we can go from this long path. But I've even gotten from this path, but it's mathematically equivalent to going through this path. We could have gone through this path, but maybe, but I2 and I2 get subtracted, and 2I1 plus I1 This is that. So a third path that we can go is this, going below and then to side and remaining on the edge and going up. If we go through this path, change in potential will be I1 plus I1 plus 2I1 plus 4I1 and 4I1. I don't think we have made the, yeah, haven't made the configuration with the, so what current is going here? See, it's I1 minus I2 going inside. So I1 minus, so a part of I1 minus I2 is going inside. That means the remaining part, it's 2 I1 minus I2, right? So I1 minus I2 plus I1 minus I2. A part of it is going inside. The remaining part must go above. I1 minus I2, that's what going above. And so we have I1 plus I1 is 2 I1, 4 I1, 5 I1, 6 I1, in fact. And then it's minus I2 minus I2 plus 2 I2. It's 1 I2 minus I2. When? What? What just happened? Sorry. Minus I2. Okay, it's minus I2, right? Minus I2 minus 2 I2. This becomes minus 3 I2, then minus 4 I2. Let me do it again. Minus I2 minus 3 I2 minus 4 I2. So minus 4 I2. R. Now if we need to find delta V in the forms of I. So we need to convert this I1 in some equation, some variable of I, of this I. See, we have three equations that are equal, so we can make them equivalent. So I minus 2I1 is 2I1 plus I2, which is which we can take the I1 on the other side, then it becomes 4I1 plus I2. The first equation and the second equation can be received by equating them. We can say I is the 2I1 that side to 8I1 minus 4I2. So equated these two. And this is equal to this equation, and the third equation is also equal to the first equation. So they must be equal to each other. It's Euclid's axiom, so we do not need to equate them now. What we need to do here is have to equate these two equations. And so if for that 4I1 on that side, 5I2 on that side, 5I2 is 4I1. Means I2 is 4 by 5I1, which we can substitute here. I2 is 4 by 5I1 and 5 fours are 20, 24 by 5. I becomes 24 by 5 I1, or I1 becomes 5 by 24. This is I1, right? I1 becomes 5 by 24I. This is what we needed, right? We needed I1 in the form of I. So let's just substitute 24 to I becomes 5 by 12, and I minus 5 by 12y 7 by 12y. So delta V is 7 by 12 IR. So we got the potential difference between A and B is 7 by 12 IR. If we divide this potential difference by the current which we force through the circuit, so we divide it by R, we get the equivalent resistance. This divided, and so 7 by 12 R is the equivalent resistance. Okay, so that was it.